Alright, so this is going to be another video about integration by substitution. Here now I have a different example, but it's closely related to the one from the previous video. So you might want to watch the previous video if you haven't already. So first thing we're going to do here is we're going to substitute out the more complex functions and try to substitute everything in to make our life easier. So here we go. So I'm going to take this x squared plus 3 and substitute that and set that equal to u. Okay, so this is taken care of. Now we still have this x dx part that we have to worry about. So I'm going to worry about this dx right now. So to figure out dx, I'm going to take the derivative of this u with respect to x, and you'll end up with 2x again. Okay. Next, I'm going to try to solve for dx. So I'm going to multiply both sides by dx, and you end up with 2x dx. Okay. Now if you notice, we still need to substitute for x dx right here, but there's a little x dx right in here for what we solve for. So what we're going to do is we want to solve for this x dx so we can substitute it in for these two variables up here. So what I'm going to do is divide both sides by 2 here. So divide this by 2, divide this by 2. The 2's cancel. Now we have x dx is equal to du over 2. So now we can actually simplify this integral, and you'll end up with something that looks like this. You'll have u times this whole thing right here is du over 2. So we put that at the end. Okay. Now this du over 2 is the same thing as saying u times 1/2 times du. Now since this is a constant multiple, I can put it in front of the integral. So you end up with something that looks like this. U du. Okay. Well, the antiderivative of u, similar to the one we had before, would be u squared over 2 plus c. Okay? But you also have to multiply everything by half, so I'm going to put a half here as well. Now this half times the c doesn't matter because c is just any constant, so I'm just going to move the parentheses over like this because half times c is still equal to just some other constant c. It doesn't really matter. Okay, multiply some by fractions here. We have u squared divided by 4 plus c. Substitute in the u squared right here, so it's x squared plus 3 squared divided by 4 plus c, and then we have a final answer for the antiderivative or an antiderivative of this integral up here. Now, last step again, a good idea would be to check your work, so I'm going to do that right now by finding the derivative of this, and I should get this up here. So here we go. So the first thing I'm going to do for this derivative is drop down the 2, bring it over for the power rule. So we have 2 times the quantity x squared plus 3 minus 1 from the powers to 1 power. Divide this by 4. Okay, times the inner derivative, which is 2x. Okay, well, this 4 and this 2 will cancel, so you'll have 1 here and 2. This 2 divided by 2 will cancel, and you'll be left with x squared plus 3 times x. Now remember that c just goes away because the derivative of c is 0. So then you're left with x squared plus 3 times x, which is exactly what we have up here. So this checks out, and that is our final answer. The next video is going to be another example, only a little bit harder, so I'm going to add an extra layer to it. So again, if you have any questions about this, let me know.